Welcome back, students and folks who happen to find this video, to another episode of Automated Speech Recognition. Let's take a deeper dive into some toolkits, specific toolkits this time. Let's start with the bomb. That is the coolest, I'm going to say the coolest ASR system right now, called Whisper ASR from OpenAI, the big bad boy company that has created ChatGPT and other AI tools. It was trained on 680 hours of audio that they scraped from the internet. And it is really good. It has both a command line interface as well as a Python API, so you can use it within a Python script, or you can use it right at the command line. It has three main functions. It transcribed English, that is, goes from audio to transcription, ASR, automated speech recognition, right? It can transcribe a lot of languages, and it can also transcribe from a spoken non-English language into written English, meaning it does transcription in a non-English language, and then under the hood it does machine translation and then transcribes it into English. So here's a little diagram of the architecture. Here are the examples in the top left of this slide here. The multitask training data, right? 680,000 hours, English transcription, any English or any non-English language to English transcription. For example, el rápido zorro marrón salta sobre, which translates into the quick brown fox jumps over. And then it does non-English transcription as well. And also it doesn't pay attention to background music playing, which is pretty cool. Anyway, here's a bit about the details, like the bowels of the system. You have log mel spectrogram here, goes into convolutional 1D network. This is getting into the neural network training. It has cross attention here, transformer encoder blocks here. Anyway, this is in the bowels of the neural network system that was used to create the software. We don't need to get too crazy into that. If you'd like to look into this more, you totally can. But we're just going to stay at a high level, just using the software as it is, as it stands. So let's take a look at it. The blog post that introduced it is right here, introducing Whisper. And let me just play a couple of samples they have sitting right here. This is pretty cool. So the first sample I'm going to play is speed talking. This person's going to be talking really quickly. I'm going to display the transcript. Let me zoom in even more on this. So this is speed talking. Ready, set.
This is the Micro Machine Man presenting the most miniature motorcade of micro machines. Each one has dramatic details, terrific trim, precision paint jobs, plus incredible micro machine pocket playsets. There's a police station, fire station, restaurant, service station, and more. Perfect pocket portables to take any place. And there are many miniature playsets to play with, and each one comes with its own special edition micro machine vehicle and fun.
Anyway, it's astounding that I can get that. It's transcribing that fast speech. And then here is some K-pop. So there's some music in the background with this one. So it's transcribing in, I guess, Korean. I don't know Korean. I assume it's Korean. Transcribing Korean, then doing machine translation under the hood, and then giving us a English transcript down here. Listen to this. Anyway, it's pretty astounding. It's got the music in the background, it's got singing, and then it transcribes in, I guess, Korean, and then does machine translation into English there. Here's some French. Listen to this. Again, it's going to do the same concept of transcribing in French and then do a machine translation and then giving us English output.
Whisper est un système de reconnaissance automatique de la parole entraîné sur 680 000 heures de données multilingues et multitâches récoltées sur Internet. Nous établissons que l'utilisation de données d'un tel nombre et d'une telle diversité.
Anyway, it's pretty good. There's a big echo. You can hear there's a big echo in that room where that audio was recorded, but did a pretty good job. I assume it did a pretty good job. I don't know French too well enough to know. And here's an accented. Listen to this one.
One of the most famous landmarks on the borders. It's three hills. And the myth is that Merlin, the magician, split one hill into three and it left the two hills at the back of us, which you can see. The weather's never good. They always say in the borders if they miss.
Anyway, some great Scottish English there. All of us have an accent, by the way. I kind of take objection to calling his speech accented because mine's accented for him, right? But anyway, yeah, it does a pretty good job there. Anyway, the amount of data that they use to transcribe this ASR or to train this ASR system has allowed it to be really robust. That's why I'm going to say, hey, it's the top one right now. Cool. So here's the code. They have the code available on GitHub, right? GitHub is a website for sharing and collaborating on code. So here it is. Here's the diagram I grabbed and put into my slide deck there. And you can pip install it very easily into Python with that little bit of code there. They say they need some other dependencies. You need FFmpeg to do some file conversion. FFmpeg is our old friend, right? It does a lot of file conversion stuff. You may need Rust as well. You can do so with that. Anyway, they have some models here. They have different size models. There's not just one model. And you can see on the far right, it says relative speed. In general, the larger the model, the longer it takes to actually transcribe the speech, to do ASR. And so the kind of the rule of thumb is if you can get away with a smaller model for your task, for your audio, then you should probably use the smaller model because it'll be quicker. For example, I often use the small model because it seems to work well with my data. The data I've tried, I've used Whisper on. So I've successfully used Whisper to transcribe L2 Spanish and L1 English, including the L1 English was an interview I did with my parents-in-law on about their 50th wedding anniversary. And the microphone was far away. I felt embarrassed as a professor of speech processing that I didn't make sure the microphone was close enough to my parents-in-law to pick up good quality audio. But Whisper did a great job of actually transcribing them even with the poor audio, and I just used a small model for that. But anyway, the idea is that the larger the model, the better the quality, but the longer it'll take to transcribe. So again, the kind of rule of thumb is if you can get away with a smaller model with your data, then it's probably best to do that to make it quicker. Cool. Anyway, here's some information about their testing of the system. They break down large version 3 and large version 2 there with two different data sets, the Common Voice 15 and the FLIRS. And this is the blue score, which is word error rate. Sorry, this is word error rate. And the lower the number, the better. So with this left-hand column here, Dutch had the lowest error rate, Spanish next, Korean next, etc. With this other data set, the FLIRS data set, Spanish had the lowest error rate at only 2.8. I think that's per 100 words. I mean, that's the idea. They're just simply testing their models to see how well they do with these different languages. So you can see there's quite a few different languages here we got, you know, kind of the big European languages, obviously including English. The computational linguistic world and the corpus linguistic world is very English-centric, if you haven't discovered that yet. But and so they have Czech and Swedish and Romanian and Cantonese and Mandarin, Catalan, a regional language in Spain, in eastern Spain, Arabic, Latvian, Hindi, all sorts of languages in here. Cool. Like I mentioned, they have a command line uses where you can just use it at the command line of your computer or of a Google Colab notebook, right? Because you have a command line, a Linux command line in a Google notebook, right? And so you can pass in several files at once and then specify the model size that you want. So this one says model medium. I'll just jump back up real quick. So they're saying we want the medium size model. They specify it explicitly like that. I think the default behavior is to use the base model. If you don't specify anything different, it's use the base model. But if you want something else, then you have to specify the model size. And so that's what they're doing right there with model medium. Here they are transcribing Japanese. And then here they're saying, hey, here's the Japanese file. It is in Japanese. And I want you to translate it into Spanish. So do transcription in Japanese and then do machine translation and give me an English transcript of what was said in Japanese. That's pretty cool. And then also you can use Python, use this within a Python script. So I'll show you both of those in a second here. And you can have more low-level access to the model if you like, as well as in Python with this type of stuff. And there's some more examples there. So this is Whisper. Let me see. Yeah, let's do some demo of Whisper real quick before we go to the next one. Let me jump out of here. Let's pull over my Visual Studio Code over to this screen. So I have a couple audio files that I recorded before I started the video. Let me just show those to you. Let's go to my downloads. Here is a little audio I recorded before the video started. Listen to this. I love teaching students how to analyze human languages with computers. It's fun and it's the bomb. Okay, so let's see if we can get that. If I say I_love is the name of the file, and I didn't point out, but this is an MP3 file. So Whisper can take MP3, M4A, and all sorts of different file formats, not just WAV. The WAV is kind of the standard format that most speech processing and speech technologies use, but it can do conversion under the hood. I believe it's using FFmpeg under the hood to do that conversion before it does the actual ASR. So let's take a look here. I've already installed Whisper with the pip install. So if I just run this right now, let's just see what it does. It's going to load up the model. It's going to take a little bit of time at the bottom of my screen right now. Let me zoom in a bit here. It is going for it. This is a little warning that wasn't actually a error. And it returns what's called a dictionary in Python, right? And it has the text, which is just the text, just a transcription. It's got other stuff in here. It's got segments. Anyway, and I just say, hey, I just want to see the text itself. And at the very bottom of my screen, it says, I love teaching students how to analyze human languages with computers. It's fun and it's the bomb. That's what I said in that audio file that I had to transcribe. So that's cool. I'll also show you at the command line. Let me just make the command line a little bigger at the bottom part of my screen. If I were to just type in Whisper, and then I'm already in my downloads. I can see right now I'm already in my downloads. And so I just say I_love.mp3 and let it go. If I don't specify the model nor specify the language, it's going to use the first 30 seconds to try and guess the language, and it detected English correctly, because that's what I spoke there. And then it transcribes it here with timestamps. It says, I love teaching students how to analyze human languages with computers. And then here's a second sentence and utterance. It's fun and it's the bomb. It does a really good job. It capitalizes I. It has punctuation. Really good. I will point out that it created several things. This command line tool creates several things. So back here, I'm back in my Finder, kind of like Windows Explorer. Here is the audio file I put in, which is ilove.mp3. And then it created these other things. It created four other files here. 5 other files? 1, 2, 3, 4, 5. It created 5 files, one of which is a JSON file. Let me just open this up and see. Let's just take a look here. Where is it going to open it up? Where is it going? Why is it? Where is it? Oh, it's going out to Firefox. So that's weird. Anyway, here is the JSON file. Let me zoom way in on that. It's a JSON file. It's a certain file that is meant to be read by computers. And so and Firefox happened to want to display it. That's cool. We'll just quit that. Okay, go ahead and quit that. Okay. Sorry. Okay. Let's go back to this point. There's an SRT. Excuse me. There's an SRT file, which if I can just grab here and just throw right there. There we go. That's a little better. At the top left of my screen, I have an SRT file, which is a subtitle file that can be paired with the video to create custom subtitles. So that's what this is doing here. The timestamps right there are used to put the subtitle at that certain timestamp within the video. And so this is the format of an STR. And so I actually did this. I mentioned the video I did with my parents-in-law. And yeah, I just created a SRT file using Whisper to make sure that all the proper nouns, names of people and places that were said in the interview came out correctly, rather than relying on YouTube's ASR system. Anyway, that's another file format, and there's some others in here. You just have a classic, good old-fashioned TXT file right here, right? It just puts it into a TXT file very simply like that with no timestamps. So anyway, that's cool. That is Whisper. Let me show you real quick before we call this good. Move on to the next system. Let me show you some Spanish. Let me go back over to this point. So I also said this in Spanish. Let me play this for you in Spanish. Let me see if I can just play this in a VLC player. Let me grab VLC. It's coming up. Right, so I said I like to use the computer, or computers would be the best translation in English, to analyze human languages. I said that in Spanish. With my little microphone sitting right here in front of me, right out of screen. And so let's go back to this point and say, Let me just clear this out so we can see more of it down here at the bottom part of my screen. I have a little terminal here, or command line interface. And so I just say whisper. I'm in the downloads already, so I can just point directly to the file name. And I'll point out that this is the M4A file. You see that right there? M4A is the file format. It's another kind of different format, not WAV. And then I say the language, so two dashes, language, space, and then you can either spell out Spanish or you can just use the 2-character abbreviation. In this case, it would be ES, or you can spell out Spanish. And then you can say, I want the model to be small. Like I said, the default, I believe, is base. But if you want something else, you can say what the size of the model you want is. Again, the bigger the model, the longer it's going to take to transcribe, and the bigger the actual model will sit on your computer. Like, it'll take more room. Anyway, here we go. There it is. Me gusta usar la computadora para analizar las lenguas humanas. Ah, bueno. And it has a timestamp right there. Good. And again, it with the command line interface, it created these other 5 files that can be used for various things. Okay. Good. So that is Whisper. I give it 2 thumbs up. It is a really good system and super easy to use. Let's jump back to my slides. I'm going to show you some other systems. Let's go back to here and go like this. Make sure we are showing my screen at this point. Good. So CMU stands for Carnegie Mellon University. They have an ASR system that does more than just ASR called Sphinx. It was developed there. Here's a link I have to it. Let's just click on this and see. Here it is, open source speech recognition toolkit. And they've been developing this for a while. I'm not sure exactly how long, like decade or 2. It's an oldie but a goodie, and kind of the OG of ASR systems, you might say. One of the OGs, I guess. So yeah, I'm going to give you a demo here in a second. It's written in Java, but it has APIs, which are application programming interfaces, to Python and C. And the typical language model comes from this corpus. It's a English Broadcast News Speech corpus. Here it is sitting on LDC, the Linguistic Data Consortium. And so this is what the corpus they used at some point in the past. They probably updated that a bit. We can manipulate 3 main components. The recognizer, which handles the signal processing. Oops, sorry, I didn't mean to. The recognizer, which handles the signal processing, like the sound processing, right? The waves coming in through air are handled by this recognizer. The grammar specifies the language model, like an n-gram language model like we created previously in a previous class. And then the linguist manages the lexis and the phonology. And I think I have a diagram. This diagram right here is pretty in-depth, and honestly, we don't need to worry much about it. It's just kind of a wow factor here. It's like, whoa, look at all these different components that are happening to do this ASR. This is what ASR systems do. Like, this is what happens under the hood or something like it. Wow. That's all I say about that. Here's a bit more, another kind of diagram. We have the raw audio coming in. I'll just circle right here in the middle of this slide. We have the raw audio coming in. We have a pre-emphasizer, like we talked about in class, right? It boosts up the higher frequency sounds. We have a windower, like we mentioned, like a Hanning or Hamming window or a Gaussian windowing effect, right? Like the makers of Pratt said is much better than any other windowing. We have a spectrum analyzer. It creates a spectrum. When we go into the mail filter bank, then we have a Kepstrom producer, which goes into the M-pointer, which goes into the CMM, and out comes feature extractor, the features coming out of this thing. Again, you don't have to worry about the details. I don't expect you to know the details. And to be fully transparent, I know a high-level understanding of this. I could not go down and break down each of these little components by myself, to be fully frank with you. But I know how to use the software. I understand the basic idea of what's happening here. You turn sound into numbers. You do some stuff with the numbers. You decode it out to orthography in ASR system. Okay. Here is another diagram. The acoustic. Let's look at the right side here. The linguist. The acoustic model, right, is what sounds come after what sounds. The dictionary is like a G to P, grapheme to phoneme type thing, like CMU dictionary, where you have the orthography and then you have a phonemic representation or even a phonetic representation in some type of alphabet. Often like the ARPABET alphabet is used, or International Phonetic Alphabet, right, IPA. Then you have the language model sitting there as well, like what's more probable, which words are more more likely to go with other words. So that's what we see there. You have a decoder, other components go into this big system. Again, I'm waving my hands a lot because, to be frank, the details aren't super important for us in this intro to speech processing class. They have their current system up on GitHub right here. They're developing Pocket Sphinx, which is kind of a lightweight version of this software. Here it is. This is Pocket Sphinx, one of Carnegie Mellon University's open source, large vocabulary, speaker independent, continuous speech recognition engines. Awesome. So it talks about how to install this, how to build it, how to use it at the command line. This is a command line interface right there. Good. I'll show you in Python. They have a Python API as well. Python API and a C API. If you want to knock yourself out with the C API, you can sure do so. I am not touching C personally, but you can if you like. I'll use Python. Here's documentation for the Python API right there, how to pip install it. Let me zoom in a bit real quick. How to pip install it. Here's a little sample demo, which I should just do right now. Let's just do it right now. Let me see if there's anything else I wanted to mention before. But let me finish these few slides and I'll give a demo at the end there. You can use it in Java if you know Java. Here's a Maven dependencies if you want to use Java to code this stuff, to use Sphinx. If you want to create a new model, a new acoustic model, they have a tutorial sitting right here, training an acoustic model for CMU Sphinx. Very in-depth tutorial on how to do that. They also have a tutorial on adapting an already existing model here, adapting a default acoustic model. Acoustic models take a long time to build, and they walk through how to do that here. You just need some sentences, a dictionary describing the pronunciation of all the words in the list of sentences, and a recording of you speaking each of those sentences. That's what you need if you need to adapt an acoustic model. Good phonetic dictionaries. They have their classic CMU Dict, which is a CMU dictionary, right? It has orthography as the first thing, and then it has an alphabet representation of the pronunciation of those words. So if we look for Earl, there's Earl, right? We have ER1, that's the R-colored schwa in alphabet. The 1 means it's stressed, and then we have an L, Earl, right, my name. They have other dictionaries as well. You can extend it. So what you can do is you can say, hey, go into this dictionary and look for the word that you heard and give me the representation in a phonetic representation alphabet. But if the word is not there, because, for example, it's a proper noun, like a name of a person or place, and it's not there, then you can extend it with the G2P tool. Oops. A G2P tool, right? G2P is grapheme to phoneme tool. Phonetosaurus, for example, or this other one, Sequitur. If you remember, we saw that little bit of the ASR system going from graphemes to phoneme or vice versa. Okay. Anyway, and if you have a logographic language, you need to Romanize it first, and that happens. That's a point. That's a process, part of the process. Good. Here's some language models they have. Let's take a look at this. Sphinx knowledge base tool. This is the new version of the LM tool. Cool. Anyway, I'll let you look at that if you like. And we need an ARPABET language ngram model file format. I don't know if you remember that. We saw that where we have all the unigrams, that is single words, and their probabilities in a log transform number. And then we have all the bigrams and all their probabilities in a log transform number, and then all the trigrams, etc. That's what you need to end up with a language model there. Good. And Pocket Sphinx it seems like Pocket Sphinx is the one that's being developed the most right now, if I'm seeing things correctly. Let's stop there and I'll give you a little demo of that. Let's go to my Visual Studio. Here is a live demo of Sphinx. So I've downloaded Sphinx on my hard drive. It's available. I'm going to use Pocket Sphinx. And this little bit of code, I'm actually going to use this package called speech recognition, but I am going to use Sphinx under the hood. Recognize Sphinx right there. So let's see how this works. If I run this, this should hopefully be a live demo. Yeah, let's see if it works. Ready, set, go. Hello, my name is Earl Brown, and I teach linguistics at BYU. Down at the bottom part of my screen, it says, Sphinx thinks you said, hello, there was Earl Brown, and his son was except you, why you. Okay, I didn't do so well. Let me try it again. Let's try one more time. Let me put the microphone, I'm going to get my mouth super close to the microphone. Ready, set. Well, let me try that again. Let me try that one more time. Ready, set. My name is Earl Brown, and I teach linguistics at Brigham Young University in Utah. Down at the bottom part of my screen, Sphinx thinks you said, my name is what? Whirled Around, and I teach linguistics at Brigham Young University in Utah. Okay, well, there you go. That's a live. It's a demo of their live microphone recognizer. Alrighty. Let's try this. Caldi. Caldi is another open source project, and it is also a good system. It is an important one. We had a student here who did linguistics at Brigham BYU, and he did a master's program in computational linguistics. And then when he went to go on the job market, he had to create a Caldi ASR system. If I understand it correctly, he had to create a system with Caldi as part of the interview process to get a job as a speech processing engineer at an AI company. So knowing this software was important for him at that time. And so here's a little bit of the history. If you'd like to look at it, it was first created at Johns Hopkins University, the Center for Language and Speech Processing at Johns Hopkins University in Maryland. And the VOSC API, those in the previous lab, we looked at the VOSC API a bit. But that was one of the options to look at. Anyway, it uses Caldi under the hood, if I'm not mistaken. Anyway, here's another kind of diagram of what happens with this system. You have speech input on the left-hand side. It goes into numbers. The MFCC, right, male frequency cepstral coefficients, fecal extraction. You turn sound into numbers. And then the CMVN is the cepstral mean variance normalization, right, is a computationally efficient normalization technique for robust speech recognition. The performance of CMVN is known to degrade for short utterances. Okay, cool. CMVN minimizes distortion by noise contamination for robust feature extraction by linearly transforming the cepstral coefficients to have the same segmental statistics. If that's all Greek to you, just realize that there's numbers, there's math happening here. And then we do a delta adder, and then we get into the hidden Markov model and the Gaussian mixture model decoder, which turns it into orthography. The cool thing about Caldi is it comes with quite a few recipes. That is like prepackaged scripts that you can look at and modify to fit your purposes and get ideas on how to use the software. It's pretty cool. It comes with quite a few recipes or scripts that you can use as a jumping off point. And there's quite a few companies that use it or have used it in the past. Big companies, right, that do speech research. Big tech companies as well at the bottom part of my screen. Startups as well. It's written in C++, which we don't teach in our department in linguistics, right? It's taught in the CS department, probably the engineering department, I imagine. I'm not sure about that. Anyway, it uses different softwares here. The BLAS is a popular language or library. OpenFST, Open Finite State Transducer library there on the top right. And it has these different components that go into it. So with quite a few ASR systems, you can run quite a few files at once, right? You need to do some scripting, have a little glue language like Python to handle looping over files, audio files, and creating transcripts for those and using the same name, right? And that's where scripting, being able to script in Python is super useful. A lot of these can do a live microphone input. You can talk into a microphone and have it transcribe in real time. You can also do it through a network and API calls to a server out on their servers out on the internet. So maybe I'll give a demo here in a minute about that. Model repositories. A lot of these systems have their models sitting there ready to be used. So Sphinx has their models sitting here. Good. Here they are. Audio data, open source models, cool. Kaldi has its model sitting here. And, right, so what do we got here? In English, ASR model trained on Libre speech, an English ASR model trained on Giga speech. Here's a Mandarin ASR model trained on free data. So they often make their models freely available to the public. Julius is an ASR system made in Japan, Japanese language model, acoustic models, cool, as well as the English model as well. Julius is another ASR system I haven't mentioned before. Let me back up to the top of this GitHub. Open source, large vocabulary, continuous speech recognition engine. And and Google, I don't know if they make their models, I don't believe they make their models openly sourced, do they? Anyway, here's some information about their transcription model. VoxForge has some speech audio data here, as well as I believe they have some models sitting here. VoxForge is an open speech data set, or it's just one data set that was set up to collect transcribed speech of use for free and open source speech recognition engines on the 3 major operating systems that are used these days. Okay, good. Oops, let me go back. Hugging Face. Now, Hugging Face, in fact, I need to update this right now. I'm going to update this thing right now. It's got thousands of ASR models. Hugging Face. Let me just go there. So Hugging Face has a page about automated speech recognition, right? Also known as speech to text, is the task of transcribing a given audio to text. It has many applications such as voice user interfaces. Cool. So here's some information about it. Here's a little video if you'd like to watch that video about it, about ASR, virtual speech assistants, all right, caption generation, like with TVs, right? You can do it you can do subtitles on the fly. Good. Anyway, here's a little bit of Python code. And if you go up to here, I'm at Hugging Face. So Hugging Face is a website where companies as well as just individuals can put up their machine learning models for the public to use. So if you click on models at the top of the screen right here where I'm circling my cursor, you click on models. And then on the left-hand side, it has different categories of machine learning tasks. Down at the bottom, near the bottom, it says audio here. And we have automated speech recognition is one of those, automated speech recognition, ASR. When you click on that, it filters that out. It just filters those. And unsurprisingly to me, the top one, that's trending the most right now is OpenAI's Whisper Large version 3. At the time recording, that is the top trending model for ASR. You can sort by other things. It defaults to sort by trending. If you sort by most likes, unsurprisingly, most likes goes to OpenAI's Whisper system right there. If you look at most downloads, we have another system here, Wave to Vec Large. Okay, so this Wave to Vec is another useful system or another popular system on Hugging Face. So anyway, the idea is that you can look at all these different ASR systems from different companies. Here, this is an individual, looks like, who probably used Facebook's Wave to Vec and did some type of fine-tuning on it and put it back up to Hugging Face, and people were like, oh, this is really good, I'll use it. But Facebook has their Wave to Vec ASR model here. These other people, other just third parties, as well as companies. Anyway, I'll let you look through here, these different models. So Hugging Face is really the place where machine learning models are put up these days for the public to use. Models can be specialized for specific tasks like lie detection or emotion recognition. So here's a dissertation here at BYU that came out somewhat recently. How many ways can you vocalize emotion? Introducing an audio corpus of acted emotion. Emotion recognition from spatial expressions has been thoroughly explored and explained through decades of research. Let me zoom in more so you can see this even better. This project builds on previous experimental approaches to create a large audio corpus of acted vocal emotion. Awesome. Recordings of 131 subjects were collected, and 13 acoustic features from 120 subjects were used as dependent variables in this MANOVA, which is a statistical test. And then the actual data that was collected is sitting right here as well. You can download the actual corpus. This is the vocal emotion corpus data. You can download it here, and you can look at information here. It's like 6 gigabytes, if I'm reading this number correctly. 6 gigabytes of stuff of audio you can download there. Cool. And sorry. And then repositories on GitHub, right? GitHub is the place where software is shared and collaborated on these days. And you can just do a search and find other sources as well. All right, let me demo how 3 systems do when I speak the same thing and give each of those 3 systems the same audio. I'm going to use my microphone. I'm going to do a live microphone ASR demo here. I'm going to have Sphinx, CMU Sphinx, as well as Google's API. I'm going to use Google's API. I'm going to send my audio out to Google through the internet and have them transcribe it and send me back the transcript. I'm going to use Whisper on my hard drive. CMU Sphinx as well as Whisper are on my hard drive, but Google, I'm going to use the API from Google. Okay, let's just give it a try, see how it goes. Ready, set. Okay, let's go ahead and do it. Ready, set, go. My name is Earl Brown, and I teach linguistics at BYU. Down at the bottom part of my screen, it says Sphinx thinks you said, but it was Earl Brown and his linguistics at BYU. Not very good. Google speech recognition through the internet says, my name is Earl Brown and I teach linguistics at BYU. Very good. Capitalized name and linguistics, no punctuation at the end. Whispers thinks I said, my name is Earl Brown and I teach linguistics at BYU with a period. Did not capitalize linguistics nor name. Awesome. Okay, good. Now I'm going to purposely put some background noise. Maybe I'll even kind of scoot back a bit away from my microphone. I'm using this Elgato Wave 3 right in front of me, right below the camera, right out of the screen. So let's play some Sixpence None the Richer, which was a band popular in the early 2000s, the early O's, you might say. Ready? I'm going to blast this. Here we go. My name is Earl Brown, and I teach linguistics at Brigham Young University in Utah. How about you? Where do you work? Okay, Sphinx thinks you said, nowhere, I'm looking right here, nowhere newsrooms around its use lunatics and put into its unions are about to where you were. Okay, that did not do a good job whatsoever. I'm trying to figure out where did Earl Brown go? Where did linguistics? Maybe he used lunatics as linguistics. I'm not sure. Sphinx did not handle that very well. Google speech recognition through their API. My name is Earl Brown, and I teach linguistics at Brigham Young University in Utah. How about you? Where do you work? No punctuation, but good. Got it. Whisper says, my name is Earl Brown. I teach linguistics at Brigham Young University in Utah, period. How about you? Question mark. Where do you work? Question mark. There you go. Anyway, Whisper, I think, won this little battle of 3. So for the next lab, you're going to choose at least 2 ASR systems and just get them working. I have a little tutorial in Python for students. And so you're going to process some input file. You're also going to do a live mode, see if you can get a live speech recognizer with your microphone working as well. And you're going to see how ambient noise affects the systems, like purposely put in some ambient noise, maybe put your mouth far away from the microphone when you're recording or doing a live demo, live recognition to see how it affects the quality. Okay, so that is what you're going to be doing. I'll leave, I'll leave those available in the LMS for students. Okay, well, thank you so much for joining. See you next time.